Geotrig, this is lesson 5. We'll call this day 1 because there's several slides. We're not going to get through all of them today. Before we start into this lesson, part A is exponents and radicals. I want to just go over those exponent rules again, just so that we're all on the same page, that we're all remember the 7 exponent rules. I'm not going to be picky on knowing the names, but you should know or recognize that if you see it, you know how to use it. So, to make things be more efficient, I will write them down. You guys tell me what you would do. X to the n times x to the m. What am I going to do? What do I do with the exponents? You're multiplying the bases that are the same. You add the exponents. So it's x to the n plus m. And if I go to the flip side of things, and I divide bases that are the same, what can you do with those exponents? Subtract them. So x to the n minus m. Everybody's good to go with those two. We also have x to the 0 power. Anything to the 0 power is 1. Make sure that we remember that. We also have a over b to the n power. We got a fraction with a power on it. What can we do? Take the power to the a or to the top and to the b to the n. Right? It gets distributed as a power, as an exponent to the top and to the bottom. We also have ones that if I do a times b with a power on the outside. This is the power of a product. Top number 4 was the power of a quotient. So that becomes a to the n times b to the n. Let's see, what else do we have here? Power of a power. So x to the n to the m power. What can you do with those exponents? Not adding, multiplying. So we got n times m. And the last one I'm leaving for the bottom so that we can talk about it. X to the negative n power. Where does it go? It goes to the basement. What only thing that goes to the basement is the object or number or variable that has a negative exponent, and the power itself will become positive. Now guys, we could switch this around. It could be 1 over x to the negative m. And the negative exponent is on the bottom. Therefore, it will go to the top and become x to the m. Now, very important, ladies and gentlemen, that you understand that these are properties. There's an equal sign. And that equal sign means that because you see this, the left side, you can combine it to make the right side. Makes sense, right? Forward position or forward. That means we also can go and say, hey, if I see something with exponents that are added, I can separate them to their own base but multiply them. Hence, like this. If I see 5 to the 3 plus 2. So what this means, obviously, this would come from 5 to the 5th power. That equals 5 to the 3 plus 2. But using that first rule, what I'll say in reverse, is that I can do it 5 to the 3rd times 5 squared. Or it's 125 times 25. It's the same value that you will get from 5 to the 5th power. These are interchangeable. So there are going to be times where you're going to use this in the forward position, sometimes in reverse. Okay? Just so that all 7 of them work that way. So the next slide is talking about what happens if I had a rational exponent. Rational exponent means fraction as an exponent. Guys, all of those rules on the last page apply to fractions. So you can add them, subtract them, multiply, divide them. All of those still apply here. What we need to realize is that there's actually more than just the one way we have up here of taking this rational exponent and switching it to radical form. This is exponential form. This is radical form. And there is a second version to this, so please write this down, is that m is on top. It's the power, technically, of the fraction. The bottom is the denominator. That's your root. So this is the nth root, so n's on the outside. So it could be a square root, cubed root, fourth root, fifth root, sixth root, that forth. Whatever's on the bottom. And then the power on top is the one that goes inside on the base. Now, we could also write it as the nth root of x, because that's what we're taking. But all of this goes to the m power. So you get to choose which one of those that you like. Okay, so that's important. One of those generally is easier to evaluate than the other. Now, we should also talk about that if you have a square root times a square root, you can actually multiply the numbers inside. So square root of 4 times square root of 4 is the square root of 4 times 4?
16.
16. And what's the square root of 16?
4.
4. So essentially, if I multiply square root to itself, you are basically canceling the square roots and becoming just what the number is. Square root of 4 times square root of 4 is 4. Do you guys get that? Do you guys understand that?
Yes.
Square root of 3 times square root of 3 is
9.
square root of 9, or just 3. The square root of x times square root of x.
Square root of x.
Square root of x squared, which is x. Okay? Now, wait a minute. Let's branch it over to here. Isn't the square root of 4 the same thing as 4 to the 1/2 power?
Yes.
Now, how do I know that? Is because what number is tucked inside this little
A
nook?
2.
It's implied to be a 2. That's what makes it a square root. What is the power on 4? Nothing's there. What is it then?
1.
It's a 1. So guess what? It's 1 inside, 2 in the nook. So it's 4 to the 1/2 power.
Oh.
The second square root of 4 is also 4 to the 1/2 power. Wait!
You just made that make sense.
4 to the 1/2 times 4 to the 1/2. Those are common bases. What do I do when I multiply the bases?
Multiply the exponents.
Not multiply the exponents, but
Add them.
add. So that just becomes
1.
4 to the 1/2 plus 1/2, which is 4 to the first power, which is just
4.
4. These two things are equal. By using this up here, I should recognize that a square root and a rational exponent end up being the same. I just showed I get the same answer.
That actually makes plenty of sense.
The rule says that if I multiply a root or a radical, sometimes we call these radicals, the same radical to each other, I could technically multiply the numbers inside, if I chose to. Look at example number 1. The first one is what kind of root? What number is missing?
2.
2, so that's a square root.
But you got a
There is a number in this one. That's a 4. So this would actually be a
Fourth root.
fourth root. So, if I needed to simplify, aka combine like terms,
Wait, couldn't you cancel out?
I can't cancel out because they're not the same
Oh, yeah.
root.
Not the same.
I can't apply the same rule I just applied up here. So guess what? I want you guys to take these things and switch them to exponent form. Wait a minute. Square root is what power?
2.
Not 2. It's 1 over 2.
Oh, yeah.
So would you guys agree that this becomes x cubed y, parentheses around the whole thing, to the 1/2 power? Yeah?
Yep.
What does the second group become then?
Wouldn't it be 2? It'd be squared, right?
It's not a square root.
No, it'd be
1 over 4.
Oh, yeah, I gotcha.
Now, wait a minute. If you take a look at this and go back to our rules, isn't that this rule? I've got some things inside to a power. That means each one of the things inside get that power. So guess what? I can take that 1/2 and multiply it in. So this becomes x to the what power?
1 and...
3 over 2?
Wait, you want us to leave them improper?
Yes, leave it in proper fractions because we're going to have to add these together. And then y to the 1/2. So that I did this. And if I do this, it'd be x to the 1/4 and y to the 3/4. Everybody with me so far? You able to see that all I did was distribute, aka multiply to the exponents. Notice that x here has a power of 1, and 1 times 1/4 is 1/4. These are all multiplied to each other. So using that associative or commutative, I sometimes get pretty close to being the same thing. I think it's associative. I think I can put these two together, my x's together. And then I can put my y's together. So isn't that just, I'm multiplying my x's. What do I do with my exponents?
Do you have to find a common denominator?
You will. I add my exponents, right? X to the 3/2 times x to the 1/4 is x to the 3/2 plus 1/4. Y to the 1/2 plus 3/4. And now, like Ty said, you need to get a common denominator. Multiply the first one by what? What first fraction by?
2.
2 over 2. Okay? That will get a common denominator 4. Hey, I'll do that the second one as well, right?
Yeah.
Because 4 just happens to be the common denominator in both cases. So, this ends up being x to the
7/4.
6/4
Wait, what?
plus 1/4. I'm going to do one step at a time.
Oh, okay.
Y to the 2/4
Yep.
plus 3/4. So it's x to the 7/4, y to the 6/4, and actually 6/4 can be reduced, can't it?
Mm-hmm.
So we'll go up here. X to the
2.
Why is it 6? It's 5.
You're heading.
oh, you guys caught it. I tried testing you guys.
You're so smart.
I know.
Were you
It'd be
testing us or was I mistaken?
5/4. No, I messed up.
Mistake.
I made a mistake. It's all right. X to the 7/4, y to the 5/4. Can I do anything else?
No.
No. Awesome. We're done with that problem.
I think everybody knows.
So, Again, we're just doing different problems that are really a lot like you guys did in the first couple lessons, but they're adding a component that's a fraction. So you still have to apply. You're multiplying, you add their exponents. You divide the bases, you subtract their exponents. Power of a power, you multiply. All of those things. Okay? So don't forget about your rules. I'm actually going to give you guys, and get common denominators, big, big, big. I'm going to give you guys a couple seconds here. Try this one on your own.
Seconds? For what? How many minutes?
Now, the biggest key, guys, is you need to recognize a few things. This exponent is only on the group that has the parentheses here. So it only applies to this y. There are a's and there are y's. In the end, you will only have a and a y, but they will have exponents. And the exponents can be made up of fractions. They can be made up of addition and subtractions. It's okay. Now, when I look at this problem, I look at it as I can automatically know that it's going to be a to the x over 2 minus 3x. Because I can ignore all the y stuff and your a bases are being divided. Which means I do what to their exponents?
Add them.
Subtract them. The y's, on the other hand, take a little bit of work. This y on top, I need to distribute the power of a power. So this becomes y to the 2 times 1/2, which is 1, minus half of negative x is negative x over 2, over y to the negative 2x. This a is on top. So if you want, you can really just extend that all the way. I still have to get a common denominator. And so, hey, I'm dividing these y bases. What do I do to my exponents again? Subtract. So this becomes a to the x over 2 minus 3x, y to the 1 minus x over 2 minus a negative 2x. What happens when you subtract a negative?
Add.
It becomes addition. So I'm going to right away change it to addition so I don't get it mixed up. Now the last thing you should do is get a common denominator. The common denominator can be different between the exponent on a and the exponent on y. So if I go back to a's, what should be the common exponent or denominator? 2. It should be a 2. Remember, the 3x is over 1. So what I do to the bottom, which is multiply by 2, I need to do to the top. So I should have a, I'll move this over, a to the x over 2 minus what? What's 3x times 2? 6x over 2. Going back to the y's now. What should be the common denominator between those? Which is 1, 2, and 1. Should be 2. So I'm going to multiply the 1 by 2 and the 2x by 2 over 2. Notice I'm not doing all of this at once. I'm not putting this all in my head and saying, hey, look what I can do. I'm doing one step at a time. So that becomes 2 over 2, yes? Minus x over 2, which was not touched, plus, what does this one become? 4x over 2. I now have common denominators all the way through. So now, put them together. This becomes a to the x minus 6x is negative 5x over 2. And the y's, 2 minus x plus 4x. Well, negative x plus 4x is what? What happens when I take a negative x and I add it to 4x? I get 3x. And then the 2, which is laid out here up front, I didn't touch. I'll bring it in now. So it's 3x plus 2 all over 2 again. And you are done. Homework for day 1 is lesson 5, page 47. 1, 4, 7, 8, 9, 10. Have a great day.